Example 5, identify and graph classical curves. Identify the type of curve given by r squared equals 8 sine 2 theta. Then use symmetry, zeros, and maximum r values to graph the function. What you need to recognize from earlier is that anytime you have an r squared and a 2 theta inside a trig function, that's going to be the lemniscate or lemniscate, if you want to think of it that way. The way you graph this, first, if you want to use a graphing tool, is you take the square root of both sides. So I'm going to write this down so that we can get our values from here. So we'd have the square root of 8 sine 2 theta. Now, normally we would think of this as being a rows because you have a number inside the trig function. And so you would double it and say, well, this has 4 petals. Well, lemniscate, you're taking the square root of it, and it actually remains as 2 petals. So this is 2 petals, which means if it's 2 petals, so to speak, you're going to have 2 maximums and 2 zeros like that. So what can we identify first? The maximum R value is the number in the front, which is now the square root of 8. So I'll put the square root of 8 here, but we know that square root of 8 is the same thing as square root of 4 times square root of 2. So the best way of writing this answer would be that it is 2 square roots of 2. That's my maximum. Now if I want to know where does that occur, I'd put the square root of 8 here. If I did so, I would have the square root of 8 equals square root of 8 times square root sine 2 theta. And now I would divide by the square root of 8. For the sake of time, dividing by the square root of 8 is just going to leave me with 1 equals square root of sine 2 theta. If you're not sure how I got that, just divide both sides by square root of 8. And now, how do you get rid of this? You square both sides. So I'm going to square, square. So 1 squared is 1 equals sine 2 theta. You would ask yourself, where is sine inverse of 1 equal to, no, rather, where is sine inverse of 1? So here, let me get a unit circle up. On a unit circle, we want to know where the y value, because sine is y. Where is y equal to positive 1? It's this spot right there. And this is pi over 2. So that means that pi over 2, you have 2 pi. And so when I divide that by 2, pi over 2 cut in half becomes pi over 4. This means the maximum occurs at pi over 4. So I come back over here. This occurs at pi over 4, which, since there's 2 petals, the other one will be directly across. So if there's one here, the other one would be directly across because it's symmetrical. So if this is pi over 4, what pi over 4 is in the third quadrant? That'd be a little bit more than 1 whole pi. It would be 5 pi over 4. So that would be how you get these two, pi over 4 and 5 pi over 4. I guess at this stage, I'll just go ahead and show you the picture. So here it is, the 2 petals. Notice this value here that's the square root of 8. That would be the square root of 8, or 2 square roots of 2. Would be right there. And so that's the max. It does happen at pi over 4, just like we said, and 5 pi over 4. The one thing I did not put over here, if I wanted to find zeros in symmetry, we could say this is symmetric with a pole. I'll do that one too. I don't want to forget that. Let me do this over here. The symmetry, it's with the pole. And the pole, or when we say the pole, we're talking about theta equals pi over 4, or the line y equals x. That's what cuts this one in half. And it appears that it might come from this end as well, but we don't usually write that way. We talk about pi over 2, the polar axis, and pi over 4. And so finally, let's do zeros. To find the zeros, what do? I plug in 0 to this equation. So 0 equals square root 8 sine 2 theta. First thing I would do is square both sides. So now I have that 0 equals 8 sine 2 theta. Divide by 8. That goes away. And so now I have 0 equals sine of 2 theta. Now I need to do the inverse of sine. So sine inverse of 0 equals 2 theta. Come over to my unit circle. I want sine To be 0, that's the y values. To be 0, so the y is 0 at this spot and this spot, which is 0 and pi. So I'll have two answers. 0 equals 2 theta or pi equals 2 theta. So this one, when I divide by 2, I still get that 0 equals theta. Over here, I get that pi over 2 equals theta. So there's my zeros. There's two of them, 0 and pi over 2. That means coming from this way and this way, I get zeros, which means I could continue on. Since there's two, they would occur, if you take 2 pi and divide it by 2, every pi. So if I add it, it would also occur at pi and 3 pi over 2. I would also get maximum, or get zeros. So again, what do? You take however many petals you have, and you divide 2 pi by that. 2 pi divided by 2 is pi, and so these occur every pi. So if you add a pi, you get this one. Take this one, add a pi, you get 3 pi over 2. Pi over 2, add a pi, you get 3 pi over 2. So there it all is. I know these values are scattered, but there are the zeros. Here's the maximum R values and where they occur. Here was my actual equation I could type in the calculator. This, what's it called, a lemniscate. Here's the symmetry. And so the title would be a lemniscate because it looks like an 8. Lemniscate looks like an 8. Okay, part B. Let's identify this one. Now it just says 2 theta. Well, anytime you have that, it's going to be a spiral. So anytime you have a theta but no trig function with it, it's going to be a spiral. So if it's a spiral, it has no symmetry. Spiral will not have symmetry. It will have a 0 at 0, so it'll start at 0. And it'll have no maximum. Let's look at the picture. You can see this is the case. It would just continue on. That's the arrow. It just means continue on like this. You only have that first 0 at 0. So only when theta is 0 can you get this because it's multiplication. So you have to have this equal to 0. But this says greater than 0, which means this one would have none because we don't include that. And so I'll put here none if theta has to be greater than 0. So now, your turn.